Zdrast. This video has a Russian theme, courtesy of Russian sort of gingerbready type stuff, Russian chocolate, a painting of a radio tower, 2 dead power banks, and a bottle of Sbiten, which we all shall test later. So this comes from Mikhail. Mikhail vocabra? I'm not really sure. My pronunciation of Russian words is terrible because their phonetics are completely different from ours. But his English is extremely good, and he says, Exhibit number 1, exploded containment cookie box, completely not certified. Everything came in a metal case for safety. 101. Xiaomi Mi 5000 mAh power bank, that's this one. Bought on February 6, 2016 in Moscow, failed on May the 10th, 2018, sometimes during a trip from Moscow to Fukuoka via Tokyo Narita Airport. No power in the output, but responds to the button and appears to charge. I've checked, when you plug a light into this, there's a very tiny pulse of light at low level, if it's going to do it. Tiny dot of light, and nothing happens. When you push the button, it kind of shows a sort of upcharged state and very dim white LEDs. We shall open that. Exhibit 2 is Celevo 7000 mAh power bank, bought on May the 11th, 2018 in Yodobashi camera shop near Hakata Station in Fukuoka. Design Japan, no power in the output, and get a strong Russian-Japanese connection here. No power in the output, no response to the button, but it appears to charge. Failed in Moscow just over a year, just long enough to get out the warranty on June the 1st, 2019. Okay. Next exhibit, a bottle of Sbiten with juniper. I initially thought this was some sort of fancy Japanese liqueur, but in a way it kind of is, but it's actually a flavoured syrup. So this is a traditional hot drink made of honey, spices, very gooey syrup, other things, in this case juniper. To make yourself a cup of Sbiten, add 1 or 2 teaspoons of Sbiten from the bottle to hot water, tea or milk. Coffee works too. Comes from Pskov Oblast. I probably pronounced that completely wrong. I have tried this. It's very thick syrupy thing. You add it to hot water like I've done here. The spices are very coarse. They tend to settle out. You have to swirl it every so often. It's almost like powdered cinnamon and stuff like that. Hold on, I'm just going to taste it. Predominant taste, I have to say, is sugar, but with the sort of hints of the spices in the background. It reminds me a lot of the Chinese herbal teas. And you might say, but it's Russian, shouldn't that be mixed with vodka? So I've mixed some with vodka. The spices are settling out at the bottom again. I shall test it and tell what it's like as a liqueur. Strong and flavoursome. It's actually very nice. It's very aromatic as a liqueur. Oh yeah, a box of cranberry in powdered sugar. I didn't realise what these were when I first opened them. I'm going to go and grab them. They're in the fridge. I just felt the fridge was the best place for them. So it's a little box of sugary balls, and I thought this was just generic candy until you bite it. And inside is a berry. And the berry is a cranberry. I'll just crunch the sugar. And it's dusted in cinnamon, so basically a cranberry rolled in sugar, dusted in cinnamon. But the strange thing about these, and I've never come across this in any other confection before, the closest I could come to would be the chocolate dipped cherries that have the liqueur inside. This one doesn't have liqueur, but it's very wet inside. It's like really juicy. It's just really unusually like a fresh berry. It's strange. Very interesting. Never come across anything like that in that same style before. Next is a Pryonic, a variant of gingerbread. Comes from the Pryonic capital Tula, or Tulla. Now, I tried this last night, and when I pulled it out, it's reminiscent of German and Dutch spiced sort of gingerbready type stuff, but what's strange about this stuff is it looks as though it's got a fairly thick icing layer on it, but it's very dry and not overly sweet. And the texture isn't so much gingerbread, it's more like a fairly firm sponge. It's nice. Unusual that it's not so sweet. And the last exhibit is 2.4, Alyonka milk chocolate in traditional, manufactured since 1965 and modern variants. I should say 1965 was a very, very good year. That's when I was born. Supposedly named after the daughter of the first woman and the first civilian in space, Valentina Tereshkova, comes from Moscow. So let's try a bit of the chocolate. This is very reminiscent of our sort of milk chocolate with Smarties. This, I'm guessing, is kind of intrigued what Russian chocolate tastes like. I'm going to just break a wee bit off and taste it right now. Is there anything uniquely different about this? I would say, I might be wrong, but it might be quite light on the cocoa solids, even for milk chocolate. But other than that, it is a fairly standard milk chocolate. That's good that it's fairly universal around the world, except in America, where you have, of course, Hershey's, which is like wax, just presumably because of the temperature requirements. I don't think Moscow will have temperature problems. So, let's start taking USB power banks to bits. That sounds like a good idea. I'll just leave this picture here. I'll just raise it up to a more focused position so you could admire the picture of the radio tower. I think there was a note about which radio tower that was. Radio tower, Shukov radio tower, built in 1920 in Moscow. Right, Spudger, I shall put this Sbiten out the way. I shall chug the last wee bit of this vodka with Sbiten sauce in it. Yeah, the herbs really do settle down at the bottom. Right, where is my Spudger? Spudger, here's my Spudger. Let's explore these power banks. I shall get the candy treats out the way. Should get this picture safely out the way as well. I shall put these down here. Let's take a look in the me unit first. Now, I'm guessing the way this opens is that the back might spudge off. It feels like a sticker, which may be hiding screws. It is hiding screws, which will hold the back plate on them. The rest might just slide out. This is when I should really have planned things in advance and got my screwdriver handy. Where is my screwdriver? I've been shuffling stuff. Yeah, this isn't good. Oh, right. No, there's one screwdriver. It's the wrong screwdriver. Where is my other screwdriver? The one that I use the most. There it is. Right next to the bench, strangely enough. So let's see if I can unscrew these. And we'll check the voltage on the battery pack inside. And we'll see what it is. And we'll see if there's anything obvious wrong with the circuitry. So this back panel comes off. Is this going to slide out? Yes, it is, like a little tray. It's a very neat, flat lithium cell. Quite a complex circuit board. This may have been the reason for its downfall. Let's zoom up just a wee tad, and there's a barcode we could just use as a focus target. Okay. Let's bring the meter in. And gingerly probe. Are those the two connections for the... Oh, I can see the problem. I guess this wire being off might be the problem. Right, tell you what, let's solder that back on and we'll see if it brings it back to life. One moment, please. And we're back in action. The problem was, I thought those wires were really, really thin. The wire that had come off was going to a thermistor, so it was sensing that there was an anomaly because the resistance was just too high for the normal operation, so it disabled the whole pack. Looking at it, this isn't the whole story on this side. If you flip it over, hidden under here, we've got an inductor here, we've got the big tabs coming off the lithium cell here and connector, but then we've also got other chips on the back. It's absolutely stuffed with circuitry, and it just makes me think, isn't this just making things unreliable when they're trying to make them too complicated? So the main chip here, again, no, actually, Have I found information on that? The computer is in the middle of an update. I'm switched back to using a Windows computer at the moment, which is a terrible idea. And it's just catching up on years of non-use. I could just go and get the Chromebook. One moment, I'll just go and do that. It was quite easy finding that datasheet. It's a Texas Instruments chip. And this controls the charging. And is it just purely the charging? Or does it do the output as well? Is that USB in? Not sure. I've got the instructions at the side here. I'll show you afterwards. I'll provide you. You can have a search yourself. You can take a look at the data sheet. But I have to say, it is 50 sheets of paper, so it's quite a big data sheet. I can see a sense resistor here. Various support components here. The ones that are of most interest at the moment are this one, which looks like a DW01 variant called a 5225J, and then a pair of Mosfets, which will be acting as a second layer of protection for the lithium cell to prevent overcharge and over-discharge, and they're 8205B Mosfets. But it's one of these things that I can understand why they're using this chip here, because it makes it much more efficient. It means they can charge the battery bank a lot faster, which is good, I suppose, for a fairly high-capacity power bank. The back of the circuit board is covered in components including more chips, and I'm guessing from the location LEDs that the other chips may be controlling those. I'm not sure. Hold on, let's just go back down to the data sheet. Let's focus down here and zoom back out. So, taking a look at that, what have we got here? Oh, it does have the boost side as well. It's got the charge mode and it's got the boost converter, so it's dealing with all that. So the other little chip in the back, and I'm wary of taking, I've already had this circuit board out and just hinged it up slightly, but it's got these big battery tabs in the back that are kind of, they look like they're spot welded onto the circuit board. And if I try and get this out, the battery is, inevitably it's glued in. You know how they do that thing that they glue these batteries in, and in the process of taking it out, it just sort of really pulls the little package up the pouch. It's not good. So I don't want to actually destroy it in the process. I'd like to actually see the capacity of that now that it's been used for a couple of years. But there we go. That is, it's got 3.9 to 70 volts input voltage range. That's quite a complex chip. It does look like a quality power supply. Okay, let's move on to the next power bank. So that one's problem was just vibration, I guess, had caused the thermistor lead to break. It's a very scratchy box there. Let's take a look at the other one. I'm going to guess that it opens the same way. This one just outwardly appears to be completely dead. Is there going to be any charge at all inside it? This has double-sided tape and it's stuck to my spudger. Very well organised. Let's spudge under here. It does feel like a label. It looks like a label. It's one of these one-way trip. This is never going to quite look the same after you've finished doing this type sort of tear downs. Okay. Screwdriver. Fairly common approach for these ones where you take the sort of retaining bracket off the back and there's a sort of skeleton inside that holds the battery. And then this plate comes off and there's padding inside. Ooh. And a sandwich of 3 cells. I think I may have to actually peel the label off at this side. I don't think that's going to release that. I think those cells may also be glued in, which is just absolutely terrible news. Oh, it's this. It's horrible. This may not be quite in focus. Hold on. As the Samo. Focus on that. How is that? Is that focused? It looks pretty sharp. Let's give it a wee another nudge. Keep in mind this is on mega zoom at the moment, so right here, that'll do. So I do have a couple more screws at the front here. Hopefully at this point, I hope the cells aren't glued in. That would be horrible. I hate it when they're glued inside something that's not accessible and there's no way to sort of push them out. But then again, these aren't really designed for servicing, are they? They're very much a throwaway thing. Oh, here's the circuit board, and now I've got that tricky decision to make. Oh, okay. The batteries are glued inside. Oh, that's not nice. That's nasty. Right, okay, back to, tell you what, let's go to, I'll pause momentarily, I'll just see if I can find out what's on this and give you an analysis. Actually, before we do that though, let's focus back down on there. Let's bring the meter back in and probe it and see if there's any charge on the cell as it is. 0.9, it may have just decided I don't want to charge that cell again if it thinks it's gone too low. Because that can happen. Right, the temptation is to cheat. The temptation is to connect a little jumper onto that and boost it up. Right, tell you what, I'm going to pause momentarily while I just find more information on this and have a wee go at boosting it. And yet another reincarnation. The chocolate here is for reference of what the other one looked like, as little bits of Smarties poking out all directions. That's quite nice. I've been tasting chocolate again. It's quite fragrant. It's quite nice. If I thought the last circuit was complex because the chip had 50 pages, this one beats it with 109 pages of information because it turns out this is a microcontroller. Let me just grab the relevant information here. We'll zoom down the circuit board. I shall nudge it back that way. We'll see if it's actually in focus. So let's start with Chinese characters. This chip over here is an IP3005. It turns out that it's a all-in-one battery protection device. Let me just try and tilt this up so it's not swamping out. So it's basically doing the job of the DW1 type chips and the separate Mosfets, but it's all good in one package. The microcontroller is a... Let's get it in here. An HR7P153, I can give you the full number, HR7P153P4SC, just rolls off the tongue, and it's made by Eastsoft. Wait, I've not come across this controller before, but it's a full-blown microcontroller with all the usual special functions of ports. That's fundamentally it. I mean, ultimately, it's a microcontroller that's just been programmed for the purpose of running this. It's not a standard chip, which has the advantages and disadvantages. One of the disadvantages being that microcontrollers sometimes do what they want to do and not what you want. This chip down here is a complementary MOSFET. Now, does that mean it's got the N channel and P channel in the same package? It does show two sources. No, it doesn't. Yes, it shows two sources with capitalization. That's odd. Two drains, two pairs of drains, and then the two gates. So I'm guessing it is. I'm not sure why they're using that particular arrangement. But what was wrong with this is the voltage had dropped to 0.9 volts, and obviously, well, I don't think the microcontroller could even run at that point, and I suppose that's maybe a weakness in this design, in the sense that once it's gone below about the voltage that the processor can run at, then the whole power bank is going to be voided, so to speak. So what I did, I stuck some little wires onto these, and I gently eased it up. Now, because this is just a single cell effectively, it's a stack of 3, but they are just wired in parallel. Because of that, there's no risk, as there is with the battery packs in, say, a laptop. There's no risk of it, one cell going flat and the other's reverse charging it, which can, if it gets reverse charged to a high degree, as I showed in another video, it actually causes electrolysis. The copper goes from one electrode to the other and it starts making conductive paths through the separator in the lithium cells, and they will develop this sort of resistance inside that means they won't hold a charge. So the ultimate test for this now is to see if it does hold a charge on its own. When you put this into charge on a proper charger, now that it's awake, if I push this button you'll see the little blue LED is lit. There's 3 LEDs, but it's just using one at the moment because the battery's not got much charge in it. When you plug it into charge, it charges about 1.6 amps. The components that get warm are, let me remember, it's this transistor here as it gets warm. No, it's not. It's this little transistor down here gets warm, plus, I a component, I think it's a resistor down here, gets warm as well. There's a few support transistors around this. There's also this little package here, which is a dual Mosfet in series with a sense resistor. It's quite an unusual design, but it is reactivated. I can prove it's reactivated by plugging something into it and showing you that we do have output again. So I wonder what happened with this one. Maybe it just sat for a while in a discharge state, because with the extra circuitry of a microcontroller, it's going to be a quiescent current, or it's possible that the processor may have crashed. That is, usually a microcontroller has a couple of advantages. It just makes it more versatile. It can do lots of different things, but that is unfortunately its downfall as well, because if it crashes in any way, if there's a software glitch, it can go and do something else that it wasn't supposed to be doing, and that can result in just battery drain and weird behaviour. In this case, not sure. Maybe one of the cells has failed. Maybe it's developed a resistance and is slowly discharging. But I would have thought it would have been down to 0 with that. So not really sure. In hindsight, I suppose, really, if I'd thought about it, instead of actually jump-start it, I could actually try to... did I try charging this before? I think I didn't. It wouldn't take a charge. But what I did, I put these leads on and then gave it a current limited supply of about 30 milliamps, 10 per cell inside, and just gradually brought it up until it was at 3 volts. And once I got to 3 volts, the circuitry kicked back in, and that's the point you could plug it in and charge it. So that's it back in action. So I'd like to thank Mikhail for sending these things through. They were interesting, very interesting, and the candy was interesting too. The gingerbread stuff also has a thin layer of what I'd describe as caramel, dulce leche type caramel. You know that stuff when you get the condensed milk and you heat it up, and you can actually leave condensed milk in the can, and you can cover it and put it in boiling water and leave it for a while, and it caramelizes inside. It's very reminiscent of that. So that's more or less it. The 2 power banks have been reanimated. This one just had the wire off the thermistor, and this one had over-discharged to the point the circuitry wasn't going to allow it to be charged again. I wonder if the microcontroller does have a hand in actually monitoring the charging process. I've got a feeling it does. I don't think there's a dedicated charge chip for that. So that's interesting. And it just means that if you got one of these style of battery packs, the Celevo, then just make sure you keep it charged, just topped up, so it doesn't go too low, or it may just not take a charge again. But there we go, that's them fixed.